All right, so we're going to talk about characteristics of linear modeling. So let's start with a couple of quick definitions. A linear function has a constant rate of change in a straight line graph. So one of the characteristics of a linear function is it has something called a slope. So the slope of the line will have a couple of different names. We could call it change in y over change in x. Would be one definition. I'm going to go back to our earlier terminology. So change in the dependent versus the change in the independent variables. Okay, typically when we are looking at a linear equation, we have, try that again. So we have a line of some kind, but we have 2 points. Each have their own coordinates. Okay, so the way I find the slope for those 2 points is I look at the change in y. So that would be subtract y2 minus y1 over x2 minus x1. It would be a physical formula that we could calculate that in. So I kind of think of it like this. We have, here we've got change in y, and here we've got change in x that we are subtracting and then dividing to represent this number slope. Okay, so a small store sells fresh pineapples based on data for pineapple prices between $2 and $5. The store owner created a model in which a linear function is used to describe the demand. Number of pineapples sold per day varies with price. For example, 2, 80 means that at $2 per pineapple, 80 pineapples can be sold. What is the rate of change for this function? We're going to add to that when he charges $5, he's only able to sell 50 pineapples. Okay, so if we kind of think about this as points, we have one point at 2, 80, and we have a second point at 5, 50. Okay, so if you think about that in a graph, at 2, we'll go by 50s here. So at 2, he's at about 80, and at 5, he's 50. So we're looking at this line right here. And so I want to figure out the slope here. So the slope is y2 minus y1 over x2 minus x1. So, and I'm saying that my second point is the 50. So the 5, 50. So 50 minus 80 divided by 5 minus 2. Okay, so that's negative 30 over 3, which works out to be 10, negative 10. Okay, so what that means then, we have a slope of negative 10. So for every dollar the price increases, the number of pineapples sold decreases by 10. Okay, so we can kind of predict based on his supply. If he's only got 60 pineapples that day, then he can predict about what price he should have, and then he'll make sure he theoretically, he wouldn't run out, assuming that's how things behave. Using the linear demand function from the previous example, predict the demand of pineapples if he increases the price by $3. Okay. So, what we got to think about, what kind of equation, or what would that, if we increase that. So if we go up by $3, we said the number of pineapples that people would buy would decrease by 10. So that would be 10 times the 3, or 30. So if he charges $3 more, then he would sell 30 pineapples less. Okay, so there are a couple of different ways that we can write the general equation of a given line. So we've talked about slope, but we're going to focus our efforts in then on writing a general equation of some kind. And the approach we're going to take is this. We're going to say the dependent variable is going to equal the initial value plus the rate of change times the independent variable. Okay. Now, believe it or not, this is something you would have encountered in high school, because our dependent variable is y in this case. The initial value you might have heard as the y-intercept of a line. We're going to call that b. And the rate of change is, of course, m. And the independent variable is x. So, in other words, y equals mx plus b. This is what you affectionately called slope-intercept form. Okay. Now, since we're talking about equations of lines, I do want to mention that throughout your mathematical experience, you actually would have encountered three forms of a linear equation. Y equals mx plus b is one of them. Just so in case you're thinking, oh, wasn't there one with a and x and b and that? Ax plus by equals c is referred to as standard form. And there's a more advanced one, and you may or may not have encountered this one, but again, since I'm talking about linear equations, I don't think it hurts to introduce this to you. Y minus y1 equals m times x minus x1 is referred to as point slope form. Okay, now each of those three forms have their pros and cons as to why you might want to pick one. For us, for right now, we're going to stick with slope-intercept form, that y equals mx plus b. But there are good reasons why we might want to pick one form over another. Okay, so let's take a second and let's talk about what slope actually measures. What does slope actually tell us? So let's take a look at a couple of real basic equations. Let's do y equals x, y equals 2x, and y equals 2x, and y equals negative 2x. What would be the differences in those different lines? Okay, well, y equals x means there's a slope of 1. And so what that says is if I go out x and 1, I go up 1 in the y. So for every 1 I go out, I go up 1. So it has this nice, straight, flat characteristic to it. Okay, the 2x says we've got a slope of 2, and that says when x goes out 1, y actually goes up 2. So for every 1x goes out, y goes up 2 full units. Sorry, I got rid of my line there. So it's a little bit steeper of a line. So negative 2x got a slope of negative 2. So what that says is if I go out 1 in the x direction, I actually go down 2. So for every 1 in the x, I'm going down 2 more units. That's sort of a negative slant to it. Now we can add a few more things. So we notice that as the slope increases, the line gets, so as m increases, the line itself seems to get taller. As the slope decreases, it sort of falls down the other direction. So we're going to look at this as a positive, negative, and then I'm going to add to this an undefined and 0 slope. These are all different types of slopes. So a positive slope sort of has a like a first, third quadrant feel to it. It goes through first and third. A negative slope would go through the second and fourth. Undefined is a flat horizontal line, and a 0 slope, undefined is a vertical line, a 0 slope is a horizontal line. Would be the nice, easy way to remember those. So as we change different slopes, we get more and more positive or go up more, negative goes down more, but slope itself has that general characteristic about it.